Okay, in this video, we are going to learn how to use our mole-heart diagram and our factor label method to do mole conversions. First of all, let's review what a mole is. So while we might think that a mole is an adorable, fuzzy little creature that burrows in the dirt, it is, biologically speaking, but in chemistry, we use it in a very different way. In chemistry, a mole is actually a quantity, much like a dozen is a quantity. And the quantity that we use for a mole in chemistry is 6.02 times 10 to the 23rd, or 6 sextillion. It's a massive, massive number because remember we're using really small particles, so we need to have a large quantity in order to work with small atoms and molecules in the lab. And remember, a scientist by the name of Avogadro did a lot of the early work with this principle. And so this number is named after him, and we call it Avogadro's number and when we refer to 6.02 times 10 to the 23rd. So now that we know what a mole is, we have to know how to use it. So the mole, or Avogadro's number, is also a conversion factor, stating that 1 mole equals 6.02 times 10 to the 23rd particles. And remember, when I say particles, I mean either atoms or molecules, depending on what we're working with. So to use this conversion factor properly when we're doing our conversions in chemistry, we have a little mole-heart diagram that will help us. So this mole-heart diagram is going to help us while doing our conversions. We can essentially use it as a map, and we can start on any place on the map and go to any other place on the map. So for example, I can use this map to convert between my mass and my number of moles. I could also use it to convert between my particles and my volume of a gas. But in that case, I have to start at my particles, and then I first have to convert to my number of moles, and then I can convert to my volume of a gas. So this map, my mole conversions table, my mole-heart diagram, is going to tell me where I need to start and how many steps I need to take to get where I'm going, and how many conversion factors I'm going to use, and what those conversion factors are going to be. So let's take a look at those conversion factors. The first conversion factor we're going to use is this one right here. 1 mole equals 6.02 times 10 to the 23rd particles. The other conversion factor we're going to use for our mass is our molar mass. And our molar mass is simply the mass in grams of 1 mole of a substance. So it's grams per mole. Our other conversion factor we're going to use when we're working with a gas. And the volume of 1 mole of gas equals, always, regardless of the identity of the gas, is always going to be equal to 22.4 liters. So we have 22.4 liters per mole when working with gas. And this only applies when we're working with a gas. The last stop, or the last section on our mole-heart diagram is this volume of a solution, our molarity, which is something we're going to work on in another unit. So it's not anything you have to work with or worry about this unit. So for this unit, we only have to worry about converting between particles, mass, and volume of a gas at STP. Now that we're familiar with our mole-heart diagram and the conversion factors involved, let's try some practice. So example number 1 asks, how many moles are in 5.6 times 10 to the 45th atoms of gold? So to use our mole conversion table, or our little chart, we have to figure out where we're starting. And they've given us, so where we're starting is what they've given us. And they've given us 5.6 times 10 to the 45th atoms of gold. So we're starting right here at particles. And they're asking us to find the number of moles. So we need to end right here. So we're going from particles to moles. So we're going to have 1 conversion factor. So whenever you're doing your conversion factors or your factor label method, always start with what you're given. And what we've been given is 5.6 times 10 to the 45th atoms. And then our next step in our factor label method is multiply by a conversion factor. And since I have atoms, I need to get rid of atoms. So my atoms need to go on the bottom. And I know from my mole heart diagram that I'm only going to have one conversion factor in here. So it's going to be a one step. So I should be able to go right from atoms to moles. And whenever I'm converting between moles and something else, it's always going to be in terms of 1 mole. So 1 mole equals how many atoms? Well, I know the conversion factor I need to use is right here. 1 mole equals 6.02 times 10 to the 23rd atoms. And now it's just a matter of doing my calculations on my calculator. So I'm going to take 5.6 times 10 to the 45th atoms, and I'm going to divide by 6.02 times 10 to the 23rd atoms. My atoms are going to cancel, and my answer is going to be 9.3 times 10 to the 21st moles of gold. So if I have 5.6 times 10 to the 45th atoms of gold, that's the same as having 9.3 times 10 to the 21st moles of gold. Now for example 2, it asks us how many molecules are in 23.8 moles of hydrochloric acid. So to figure out where we're starting, and where we're starting is what they've given us. So they've given us 23.8 moles of hydrochloric acid. So we're right here in the center at our mole. And we need to go out to molecules. Remember, particles is either atoms or molecules. So we're going from our mole to our particles. So in this case, we're going to be converting specifically to molecules of hydrochloric acid. So it's a one-step conversion with one conversion factor. So always start with what you're given, which is 23.8 moles of hydrochloric acid. And then our second step in our factor label method is multiply by a conversion factor. And what we have is what we want to get rid of. So we have moles. So we need to get rid of moles. So it needs to go on the bottom. And since I know it's a one step, I know I'm going to be able to convert immediately to molecules. So I can put that right on top. So whenever I'm converting with moles, it's always going to be in terms of 1 mole. So 1 mole equals, and my conversion factor, I look back up here, and 1 mole equals 6.02 times 10 to the 23rd particles, which includes molecules. So if I have 1 mole, I have 6.02 times 10 to the 23rd molecules. And I put that into my calculator, and I get 1.43 times 10 to the 25th molecules of HCl, of hydrochloric acid. So 23.8 moles of hydrochloric acid is the same as 1.43 times 10 to the 25th molecules of hydrochloric acid. Okay, finally let's take a look at example number 3 that asks how many liters would 12.4 moles of oxygen gas occupy at STP? So we're starting at our 12.4 moles. So we're right here in the center of our diagram, and we want to find out how many liters that would be. And since it's liters of a gas, I can go right to this step, because remember, we're not going to be doing our volume of a solution using our molarity conversion for this unit. So as long as we have a gas at STP, we can use this step right here where we go between moles and volume of a gas. So always start with what you're given, and we're going to start with our 12.4 moles of gas, and we're going to multiply by a conversion factor. And from my map, I know it's only going to be a one conversion factor problem, or a one-step problem. So I'm going to have moles on the bottom, since that's what I want to get rid of, and liters on the top. And I always do my conversions in terms of 1 mole. And my conversion factor for this is going to be my molar volume, which is 1 mole of gas always equals 22.4 liters, regardless of the identity of the gas. As long as it's a gas, 1 mole of any sort of gas will take up 22.4 liters. So now my moles are going to cancel, and 12.4 times 22.4, and I'm going to get 277.76 liters of O2 gas. And even though this is a Brinkelhoff, notice I didn't have to multiply anything by 2, because this molar volume is always going to be 22.4 liters, whether your gas is a Brinkelhoff or not. In the next video, I will show you how to go between mass and moles and how to calculate your molar mass, as well as how to do multiple step conversions to start at one place on your mole-heart diagram and go to another corner of your mole-heart diagram using more than one conversion factor. So to learn how to do that, take a look at the next video that I've posted and bring any questions you have with you to class.